Hi, now here we've got an example on finding the centre of mass of a framework of two rods. I'll read the question through, but if you'd like to pause the video at any point and have a go, do feel free and come back when ready and check your work solution with mine. Now what we've got here is two uniform rods AB and BC are rigidly joined at B, so that angle ABC equals 90 degrees. And rod AB has length 0.5 meters and mass 2 kilograms. Rod BC has a length of 2 meters and a mass of 3 kilograms. And the centre of mass of the framework of the two rods is at G. And what we've got to do is find the distance of G from BC. Now whenever I get questions like this, I like to draw some axes in, and we'll have a y-axis and an x-axis, something like this, okay? There's my x-axis, there's my y-axis. And I've got these two uniform rods, AB and BC. Let's say we have AB going up like so. This is the point A. And we're told that this rod is half a meter in length. So this y coordinate up here would be 0.5. Okay? And then we've got the uniform rod BC, which is of length 2 meters. So let's just say that takes us to C here, and this x coordinate here would be 2. Now they're uniform rods, and the mass of AB, we're told, is 2 kilograms. So being a uniform rod, that mass is going to be in the middle there. So we'll have that as 2 kilograms. And for BC, its mass was 3 kilograms. It's a uniform rod, so we'll just put the 3 kilogram mass there. Now the centre of mass is at this point G. So let's say that we've got G, say, somewhere around here. It's not drawn accurately, okay, but it's just to signify that that's G. And we'll say it's got coordinates x bar, y bar for the centre of mass. Now, we think of all the centre of mass of these two rods situated at this point here. So that's going to be a total of 5 kilograms. So just indicate that that's 5 kilograms. Now to work out the distance that the centre of mass is away from BC, this distance, this vertical distance here in other words, which is y bar, what we do is we take moments about BC. Okay? So if we just say take moments about BC, then what we have is the total mass, which is 5 kilograms, multiplied by the distance, the perpendicular distance to BC, which is essentially y bar, has to equal the sum of all the moments of the particles about BC. Well, if we start with the 2 kilogram particle, it's going to be its mass 2 multiplied by this distance from here to BC, which is going to be a quarter of a unit, okay, quarter of a meter. And when it comes to the moment of the 3 kilogram mass, well, it's on the x-axis, so its distance is 0. So we can neglect that. So if we work this out, what we have got is that 2 times a quarter is a half, and if we divide both sides by 5, you end up with y bar equaling 1/10, or as a decimal, 0.1 meters. Alright? Now for the next part, we're told that the distance of G from AB is 0.6 meters. And the framework is suspended from A and hangs freely in equilibrium. And we've got to find the angle between AB and the downward vertical at A. So let's just sketch this down here first of all. What we've got is our two rods. Okay, we've got the rod AB and the rod BC. And we know that the centre of mass, let's just put it in here, at G, okay, we've seen that it is 0.1 meters up from here. Let's just mark that in as 0.1 meters. 0.1 meters, that's that distance up there. But we're also told that that distance is 0.6 meters from AB. So we've got 0.6 meters across here. Okay, so we've got to work out the angle that AB will make with the vertical when we hang it from this point up here. Now, when that happens, when you hang something, the centre of mass always aligns itself vertically below the point you're hanging. So, in other words, what we've got, if I could just sketch it over here, is if we hang this from A, we're going to have something along these kind of lines. Let's see if we can just draw our rods. Okay, we've got AB here and we've got C down here. And the centre of mass will be, say, at a point down here, vertically below A. Something like this, okay? And this point here is G. Now if we're to find out the angle that AB makes with the vertical, in other words this angle in here, which I'll call theta, then what we do is we just work off a triangle. If I just mark this dotted line in here on this diagram, it's going to be that one there. Not that I've made it dotted, but the angle that we want is this one here, theta. And so we can work off a right angle triangle. We can see that if I was just to complete this across here, okay, we'll just mark that in green, the right angle triangle we're looking at is this one here. We can see this distance is 0.6 meters. I know this is 0.1 meters, but the length of AB is half a meter. So this length will be 0.5 minus 0.1, in other words 0.4 meters. Now by using trigonometry for this right angle triangle, the tan of angle theta compares the opposite side, 0.6 meters, to the adjacent side, 0.4 meters. So that's how we're going to get theta. Theta becomes the inverse tan of the opposite side, 0.6, divided by the adjacent side, 0.4. If you work this out on your calculator, I'm working in degrees mode, you should find you end up with 56.30 and so on. So if we round this, say, to 1 decimal place, it's going to be 56.3 degrees to 1 decimal place, 1 dp for short.